Hi folks, it's 7:30, so we're going to get started now. Welcome to our talk tonight and happy Native Plant Week. I'm Vivian New, the president of the Santa Clara Valley chapter of the California Native Plant Society, and welcome to our talk tonight. Before we get started, I'm going to just go over a few things about our chapter and some other things, and then we'll launch into the talk. So, oops, what's going on here? So first of all, these talks are not just the speaker and me. We actually have a whole team in the background keeping things running. So tonight we have Judy Fenerty, who's our QA moderator. She'll be reading questions to our speaker, and Madeline Morrow, who is our YouTube moderator. So if you are on YouTube, Madeline will be watching the chat there, and she'll be conveying all the information over to Zoom so that we can answer your questions or deal with any other issues that might come up. And then we'll send that back over to the chat on YouTube. And I'm also doing tech tonight, so I'm taking care of Zoom and all the other stuff in the background. And our speaker tonight is Ryan Odell. And we are part of the California Native Plant Society, which is an environmental society that looks after plants, native plants in California. We were founded in 1965, and we have over 10,000 members now, spread in 35 chapters going all across California and into Baja as well. We all even have a chapter that's not associated with a specific location in California, our bryophyte chapter. So if you're into mosses, we also have a chapter for you. Our chapter covers Santa Clara County as well as southern San Mateo County. And CNPS is all about saving native plants and their habitats. And we do that with science, education, conservation, and gardening. So if that sounds interesting to you and you are not currently part of CNPS, we would love to have you join us. More people means more power, more ability to affect change. And so it's really wonderful. If you'd like to join, like I said, we would love to have you. And if you join, you'll get 2 magazines. Actually, Fragments, which is about to be renamed, and Flora, which is our other journal, so one of them is more science-oriented. Flora is more general interest, and they're both really fun and interesting magazines. You'll also get our chapter newsletter, which is the Blazing Star, that tells you about all these events as well as other interesting articles. And you get discounts at local nurseries that are participating in this program. And if that sounds good, just go to cnps.org/join and you'll be able to sign up online. And as I mentioned at the start, this is Native Plant Week, and there are a lot of things going on both in the chapter. For example, this is one of our Native Plant Week activities, and elsewhere on the state. So if you go to our website, cnps-scv.org, and go to Native Plant Week, actually it's right there on the front of the website, so you don't even have to go to Native-Plant-Week. You can see all the different activities that are going on, and there's a lot of really fun things. So take a look. And the other things that we have coming up is on Friday, our photography group is meeting, and that is open to everybody. So even if you're not a photographer, if you just like to look at pretty plant pictures, that's an enjoyable meeting to join. And if you are a photographer and you have pictures that you'd like to share, please join as well, and you can share your pictures. You'll find out more information about it either on our meetup group or on our website, cnps-scv.org. And then we have a talk coming up the first week of May. It's from Trails to Gardens, Saw It, Loved It, and Planted It by Stephanie Morris. That one should be very interesting. Stephanie hikes a lot, and she's also an incredible gardener and landscape architect. And she's seen plants on the trail that she's realized would look great in the garden, and then she went out and, found them and put them in her garden. I mean, she didn't collect them, she found them in nurseries. So she's going to be talking about some of the really great plants that you can see both when you're hiking and in gardens. And if you would like to get a regular reminder about the things that our chapter is doing, please join our news email list. That is the easiest way to get a reminder about what's coming up. We send out just one message a week, and it'll tell you about what's going on in the week and in the next week or two afterwards. And it also has interesting information about other activities elsewhere in the state. So it's a great place if you like native plant activities to find out more about them. And you can join by sending an email to this address on the screen, or you can just go to our website, which also has that information. And because it is Native Plant Week, oh, excuse me, I have a parrot and she has no mute button, so you'll just have to, sorry about that. Anyways, our nursery has a bunch of Native Plant Week specials. With every order placed this week, you get a free Dudleya and wildflower seeds. We also have a limited supply of $4 showy milkweed in 4-inch containers. We only one per customer. And we have $6 Arroyo willows, which according to Calscape, this is the tree that hosts the most butterflies and moths. You do need a moist location if you're gonna plant that one though. And so if you're interested, you can shop anytime, 24/7, because it is an online nursery and it is open all the time. Just go to our website, cnps-scb.org, and there's a link right there on the front page to get to the nursery. And you place your orders online, and then you can either schedule a pickup at the nursery or have them delivered if you live between Belmont and San Jose. And in addition to plants, we have t-shirts like these Going Native garden tour t-shirts that you can see on the screen over here. We also have those native plant live here signs and a variety of books. So there's a whole slew of great plants and plant related items that you can get at our nursery store. And if you are looking for a volunteer opportunity, we could use more help. And so if you can point and click, you can type, and you're comfortable switching windows, that's all you need to do to be able to help us with these Zoom sessions. And as I mentioned before, we have QA moderators, YouTube moderators, and these are fun and easy jobs. And if that sounds like something you'd like to help with, just send a message to Johanna Kwan or Madeline Morrow, and their email addresses are here on this slide, or you can go to our website and they're on our officers and chairs page, their email addresses. And finally, before we get into the talk, there are a few things that just housekeeping items. So I'm going to hit mute all, make sure everybody is muted now. If you have any questions though during the talk, just type them into chat. Doesn't matter if you're on YouTube or on Zoom. Type them into chat. Madeline and Judy are monitoring, and Judy will be asking all the questions to Ryan at the end of the talk. And we do expect to finish by 9 o'clock. So now I'm going to turn it over to Judy to introduce Ryan. Go ahead, Judy.
Hi, everybody. Just want to introduce Ryan. He has been a natural resource specialist with the BLM Central Coast Field Office for 14 years. His primary duties with the BLM include rare plant, and BLM here is Bureau of Land Management. His primary duties include rare plant survey and endangered plant species monitoring and recovery in the central inner South Coast Ranges and San Joaquin Desert. And for some of us, I know we never were quite sure where that was, but I think he'll explain that tonight. And a few of us have been lucky enough to go on field trips offered by the BLM in that area in past early seasons to see some of the special plants there. So not in the last couple of years though. And some of you may also know Ryan because he has collected and reported extensively in Cal Flora across the central part of the state. So you may run across him if you're searching for interesting plants on Cal Flora, as I have done in the past. So welcome, Ryan. Thank you for doing this tonight.
Thank you very much. Hopefully folks can hear me pretty well. So yes, I'm going to present on flora of the San Joaquin Desert, and I'll talk about what the San Joaquin Desert is here throughout the presentation. So most of the areas I'm going to talk about in the San Joaquin Desert, because I'm most familiar with them, I'm going to talk about these areas within these are BLM lands within the Central Coast Field Office area, which includes Pinoche Hills, Toomey Hills, Griswold Hills, and Ciervo Hills. And these are located in more or less western Fresno County and southern San Benito County.
Hi, Ryan. We're not seeing your slides yet.
Oh, sorry. Am I not sharing still, or?
You're not sharing yet. One moment, please.
And actually, while Ryan is doing that, I realized I forgot to welcome people who are new to our talks. We love to hear about how you found out about us and where you're from. So if you're new, just type that into the chat if you don't mind. Thanks. And Ryan, there we can see your slides now. So I'm going to shut up.
Me too.
Okay, so can everybody see them now?
Yes,
No,
it's
on
going.
that presenter
no.
mode though again.
Yeah, fix this. Sorry about that. Some technical difficulties. Okay, so hopefully everybody can see my slides now. Is that correct? Everybody can see them? Good. Okay, great.
Looks awesome. Looks awesome.
Okay, great. Sorry about that. So yes, tonight for the San Joaquin Desert, I'm mostly gonna focus on BLM lands because those are the areas that I'm most familiar with. So I am from the Central Coast Field Office of BLM, which is displayed here. And that includes, for the San Joaquin Desert lands that we manage, is Pinoche Hills, Toomey Hills, Griswold Hills, and Ciervo Hills in western Fresno County. And most of those lands have a conservation designation of Ciervo Pinoche Natural Area and the Pinoche Coalinga Area of Critical Environmental Concern. And so the other area I'll also talk about, the more or less bookends the San Joaquin Desert on the north and south ends, is Carrizo Plain in the Bakersfield Field Office area. And that is designated national monument. It's probably the area that most people are most familiar with for the San Joaquin Desert. So we're going to talk about the climate and flora of a desert. You first need to define what is a true desert. And so a true desert, the most the consensus or the scientific consensus of defining a desert is basically that it must have an arid climate, which is that it must have less than 25 centimeters or about 10 inches of average annual rainfall. And also that equates to basically what they call an aridity index of less than 0.2. So more or less for deserts, which the condition you have is that the temperature, the evapotranspiration rate, high heat is much, much greater than the water supply. More or less there's low rainfall. And other features that people normally associate with the desert is that the perennial vegetative cover is quite sparse. It's usually quite barren in appearance, very bleak looking. Plant species that are especially adapted to arid climates. And these can include a high proportion of annual plant species that their adaptation is essentially they escape the extreme conditions or drought of a desert by going back into the seed bank. Additionally, you'll have perennial species that have very reduced leaf surface areas, like little leaves, and their leaves will be waxy and have reflective leaf cuticles. Then lastly, you can have perennial species that have a high proportion of CAM and halophyte species. So CAM is a crassulacean acid metabolism. That's kind of a drought adaptation. You can also have succulents and things like that as well for water storage. And so lastly, you can have landforms and soil characteristics that reflect the arid climate. And these can include what people typically associate with deserts like sand dunes or arroyos, like seasonal drainages. And then additionally, you can have what they call aridosols, which are soils that form under these arid climates. These will be soils with carbonate, gypsum, and salt accumulation. So working with that definition of what a true desert is, now I'm going to go on and talk about the actual climate and flora of the San Joaquin Desert. as I talk about this, mostly I talk about in the context, and hopefully people are fairly familiar with this with using the Jepson manual. I'm going to talk about it in the context of the geographic subdivisions of California that have already been established. In particular, I'm going to focus on that center part that's the green, that's SNJV, is San Joaquin Valley. So these are maps, more or less, of the precipitation and temperature throughout California. The base data for these is PRISM climate data. And then in the background, you can see all the little lines of the geographic subdivisions. And so what I did with basically defining what the San Joaquin Desert is by the climate is in the GIS layer was selected the precipitation that is less than 25 centimeters or 10 inches. And that defines that polygon, which I have partitioned out from San Joaquin Valley geographic subregion and named SNJD for San Joaquin Desert. And then additionally, as a comparison, I've also delineated in the Mojave Desert, DMOJ, the western portion, which is sort of that diamond shape there. I'll be talking about those throughout this talk. So basically, when you look at this precipitation map, for the red and sort of like the reddish orange portions, those are the arid climate that would fit the definition of a desert. You see pretty clearly, obviously, Sonoran Desert, Mojave Desert show up red, and orange. Then you see the more or less the southern, like 2/3 of San Joaquin Valley shows up as that red-orange color. You also see that on the right, the temperature map for southern San Joaquin Valley really is almost the same as the western Mojave Desert there. So with those two climate components of precipitation and temperature, those factor into this calculation. Is called aridity index. So the aridity index is a true measure of more or less what how dry the climate is, essentially. And so part of the definition of a true desert is that the aridity index is 0.2 or less. And so in this figure on the left, you can see very clearly that this area, the San Joaquin Valley, this southern 2/3 more or less quite clearly fits that description of a desert there, as does obviously most of the rest of the desert, the Mojave Desert, Sonoran Desert, and portions of the Great Basin. And then on the right there, you have what is translated into the true climate. The can calculate basically what the climates are globally across the world. And those calculations have to do with temperature and precipitation as well. And these are called Coppen Climates. And you can see there in that area that delineated for San Joaquin Desert, those Coppen Climates are clearly within what would be defined as a desert. You can see like the light orange, the orange and the pink and the red colors are desert climates. You can see that those extend from Great Basin through the Mojave, the Sonoran Desert, and very clearly into the southern San Joaquin Valley there. So the name of the San Joaquin Desert, where did that originate? So the first example I found of actually where this originated was Holland and Keel proposed something they called the West Central Valley Desert here in the California Vegetation publication. And so this is the first example I found essentially of a formal description of the San Joaquin Valley being called formally a desert. Interestingly, though, and I looked pretty hard in the literature, this name, this West Central Valley Desert, was never actually adopted into any subsequent literature. I couldn't find any references beyond the original publication in California Vegetation. So what happened, though, is in 2011, Germano et al., they published this paper called The San Joaquin Desert of California, Ecologically Misunderstood and Overlooked. And this was the first time, essentially, the San Joaquin Desert was formally described and then essentially adopted into the scientific literature. And the way that they defined it, they looked at a combination of the climate, the aerosols for soils, and the distribution of species that are essentially endemic to the San Joaquin Desert. And they more or less came up with the little map that's in there delineated by the yellow is what they mostly defined as the extent of the San Joaquin Desert. And so this name has stuck essentially since 2011 as a formal description of the San Joaquin Desert. There's been at least 20 publications subsequent to that that have actually used this formal term of San Joaquin Desert. So if you ever driven down Interstate 5 between the Bay Area and Los Angeles, this will more or less be your view for about 200 miles. Now, if you're looking out the windows, most people are just trying to get pretty quickly from the Bay Area down to LA. And it's just mile after mile, essentially. It looks like ag fields, usually a lot of almonds, a lot of pistachios, and some grassland, what essentially superficially look like grasslands, and then with some hills in the background. So part of this is one reason why it took so long to recognize the San Joaquin Desert is superficially, it doesn't look much like a desert here. So it's a good question of why did it take so long to recognize the San Joaquin Desert? You know, it was only originally formally proposed in 95 and only sort of formally accepted from 2011 and later. So the main reasons they've been able to come up with as to why it's taken so long to recognize it is one, the San Joaquin Valley is entirely surrounded by a non-desert Mediterranean climate. And basically it's geographically separated from the other recognized deserts, including Great Basin, Mojave, and Sonoran. Historically, a substantial portion of the valley floor was actually occupied by lakes and wetlands. And that brings up an interesting question. Can lakes and wetlands exist in a desert? And I'll answer that question on the next slide. And so a third reason is there was very early extensive invasion by non-native annual grasses, and that basically caused the valley to superficially resemble a grassland. And so therefore, when early ecologists started looking at this area, they interpreted that is that the valley was a degraded perennial grassland. And unfortunately, this notion was perpetuated through the literature and persisted for a pretty long time and led people astray from the reality that actually is a desert. Fourth, there's been very extensive habitat conversion of the San Joaquin Valley floor to agriculture, urban areas, and also for fossil fuel extraction, such that less than 40% of the San Joaquin Desert ecosystem area actually remains. It's quite possibly the most imperiled desert in the world, and at least in North America. And so the last reason why it may have taken so long to recognize as a desert is there's really a lack of what people would associate with iconic desert southwest plant growth forms like cacti and yucca and things like that. And I'd say overall, a major reason is that more or less some of the desert plant communities are fairly poorly described, is how it's put that. So this is a map, more or less, of the historic vegetation of the San Joaquin Desert. And so, I mentioned, can lakes and wetlands potentially exist in a desert? And the answer is yes, they actually can. So even though the climate can be arid, you can have lakes and wetlands in a desert because the mountains, the Sierras, capture rainfall and they can feed it to the basin. So you can have something that looks very lush, have lakes and wetlands, but the climate is technically arid. And so this map is an older map, actually includes a natural community. It's called a grassland. And so here's kind of perpetuation of the notion, the people thought it was grasslands, but probably a better term for this is I said actually extensively an invaded annual foreland and not really a grassland. So here's a good example of sort of heavily invaded San Joaquin Desert annual Formland. This is typically what you'll see is you have some of the native shrubs in there is Atriplex polycarpas, and then just a blanket or a carpet of red brome. This is very extensive across the landscape. And so you can imagine why early ecologists were perplexed by this and thought that this was really a grassland, and it really kind of does look like a grassland. But in reality, this is probably actually the native condition of what it would have actually looked like. And this exists in some areas where you have extensive grazing to sort of really knock back the non-natives, including like red brome and erodium. And so you typically have a pretty good cover of native annual forbs or desert annual forbland. So in describing the San Joaquin Desert, probably one of the best descriptors of it is to try and describe what the endemic plant species are to the area. So San Joaquin Desert actually is quite floristically distinct. And I went through all of the records, more or less, of plant species in what I have delineated as the San Joaquin Desert to identify what the endemic species are and what some near-endemic species are. I was able to identify that there are at least 40 strict endemic plant species, which I've listed below. And then there are 37 near-endemic plant species, which I actually don't have listed here. And so in this list of species, there are 6 species or state or federally listed as threatened or endangered, which is 8% of the flora of San Joaquin Desert. And 32 of the species, or 42% of them, are actually CRPR list 1Bs. So there's a lot of rare endemic species essentially in the San Joaquin Desert. And there's 3 that I've highlighted in their light yellow. And these are actually undescribed species. We're continuing to actually find species in the San Joaquin Desert that haven't been described yet. So additionally, in my examination of the plant species that have been reported in the San Joaquin Desert, I found that there are actually numerous species of that are in the San Joaquin Desert that are essentially Mojave Desert disjuncts. There's 106 species actually identified total. And so these are species basically that they either sort of like equally half and half sort of share a range. It's in the San Joaquin Desert and the Mojave Desert, mostly the Western Mojave Desert, or their core ranges are mostly in the Mojave Desert, and there's maybe like a few populations that are in the San Joaquin Desert. But there's 106 species total. So these species actually comprise about 18% of the species diversity of the San Joaquin Desert. So immediately you can see there's a pretty large proportion of the flora that's very directly related to the Mojave Desert. So what I did after I identified all these species, I did what's called more or less a floristic comparison across all of the floristic subregions that are identified in the Jepson manual. And with the floristic comparison, it was more or less just comparing what species are in one floristic subregion with the other. And so the figure on the left is a percent similarity of the San Joaquin Desert, which is that big area in orange, SNJD, to the other floristic subregions. And so basically what I found in doing that is that the San Joaquin Desert is quite floristically distinct, but it's still about 60% similar to the remnant subregion that was left over after I carved out San Joaquin Desert. It's about still 60% similar to that. It's also about 46% similar to the Sacramento Valley to the north, farther to the north. It's about 44% similar to the Western Mojave Desert, and then 42% similar to the inner South Coast Ranges, which is to the west of it. So then on the right, I basically compared the percent similarity of that diamond, the Western Mojave flora, to the other floristic subregions. And so what an interesting thing I found basically about that is that that diamond, that Western Mojave Desert area, is actually 44% similar to the San Joaquin Desert. And that diamond is also only about 56% similar to the rest of the Mojave Desert. So a very interesting thing is that Western Mojave Desert region is almost as equally similar to the San Joaquin Desert as the rest of the Mojave Desert. So these maps show the percent. The one on the left is a percent of the San Joaquin Desert endemics, those 40 species that identified, the percent of those endemics that are found in other floristic subregions, or it's actually the total percent, which includes the strict endemics and also the near endemics together. And so you can see there that more or less those strict endemics and those near endemics, most of them are in the San Joaquin Desert. And then more or less there's kind of a equal amount sort of around the rest of the areas, with a pretty clear connection back to the desert regions of the Mojave. And then the map on the right is the percent that of the Mojave Desert disjunct species, those 106 species that are in common with it, that are found in the other floristic subregions. So those 106 species that in that diamond, the Western Mojave Desert, where are those found in the other regions? And so with that, you can very clearly see the connection of the flora of the Western Mojave Desert with the linking more or less the Mojave Desert with the San Joaquin Desert, and very clearly associating the San Joaquin Desert back with these other arid regions of the more commonly recognized desert regions of California. So with that, I'm now going to go through for the pretty plant photos, which everybody's here for. I'm going to talk about some of the more iconic San Joaquin Desert species that people associate with the San Joaquin Desert. And so this is Bakersfield cactus, and this one's federally listed endangered as a fairly small range. It's mostly down in the Bakersfield area. So there actually is a cactus in the San Joaquin Desert. So that tells you it's definitely a desert. There's another strict San Joaquin Desert endemic. This one's Eastwoodia elegans, yellow Moccaster. And this one was found by Alice Eastwood, and she's really an icon herself. You know, she's an early California botanist, and here she is pictured in 1938, standing next to her namesake, the Eastwoodia elegans. This one's California jewel flower. This one's also federally listed endangered. There's very few populations of this left. We have one population in our BLM lands near Coalinga, and most of the rest of the extant populations known are Carrizo Plain and near to there. This one's Monolopia kingdoni, San Joaquin woolly threads. This one's also federally listed endangered. And this one used to be across the San Joaquin Valley. Flora is now primarily limited to the western San Joaquin Valley. It extends from Pinoche Hills in my BLM field office area all the way down to Carrizo Plain. And this last one is Ariastrum hooveri. This one used to be federally listed and was actually delisted in 2003 after they found very large, kind of extensive populations of it. It was sort of overlooked because you can see the flower is quite small. And this one is strict endemic of San Joaquin Valley, actually still found throughout a lot of the still wildland areas of the desert that have not been developed. And as I mentioned, there continue to be new species found in the San Joaquin Desert. This one was recently described in 2018 as a Navarretia pinochensis. This one's actually a local endemic to Pinoche Hills and Cantua Creek area. And it's a CRPR 1B. Here's yet another one that's actually yet to be described. This one was named by Jim Reveal, but he passed away, before he could actually describe it. So this one's still lingering out there in need of formal description or formal recognition. It shows up in Cal Flora records mostly as Corzanthe spinosa, which would be a major disjunct. But anyways, this one is also a local endemic, mostly to Pinoche Hills, Little Pinoche Valley, and western San Joaquin Valley. So now I'll go on to talk about some of the San Joaquin Desert vegetation types. I talked a little bit, or touched on it a little bit, about the fact that the vegetation types are not well described for San Joaquin Desert. I think that's partially why it's not well recognized as a desert. So I'm going to refer back a little bit to Holland and Keel. They have a nice sort of table here on the right that shows the relationship between elevation for a climate gradient and aridity, more or less, in the effects on the woody vegetation types in deserts. And I more or less use that as a platform to talk about the same kind of things going on in San Joaquin Desert with respect to elevation and aridity. So primary vegetation types you have in San Joaquin Desert, if you want to call it that, the wettest portion, which is still quite dry at about 10 inches, you'll have California juniper woodland. Progressively drier, you progress through these vegetation types, include the distinctive San Joaquin Desert scrub, and then through saltbrush scrub, alkali sink scrub, and then in some desert riparian areas, there's also a distinctive vegetation type there as well. So essentially you have woody vegetation types that change with increasing aridity gradient and an increasing soil salinity gradient. And additionally, you have a very diverse vegetation types that are in the desert annual foreland. And these vary by soil type, and so I'll describe some of these in detail in a little bit. And so this is more or less gives a broad overview of the San Joaquin Desert, looking from a high point, sort of at the edge of the desert, looking down towards the more arid portion of it. So at the bottom of that image there, it is less arid and the soils are less saline. It's about 10 inches average annual precipitation. The soils are more or less non-saline. Out in the distance there on the valley floor, it's in the extreme rain shadow of the range. It's more like 7 inches average annual rainfall, and the soils are more saline or sodic. So there's a gradient here. So the first vegetation type we're going to talk about here is a California juniper woodland. This is, as you can see here, it's pretty much junipers kind of widely scattered across the landscape. And in here you'll have Ericameria linearifolia sort of at the edge of the San Joaquin Desert, or the upper end of it. As you get a little bit drier, you start to get into this pretty unique vegetation type for the San Joaquin Desert that I call the San Joaquin Desert scrub, and Holland and Keel kind of called it the West Central Valley Desert scrub. So they also recognize that this is clear, distinctive desert scrub vegetation type for this desert. And there you'll find Ephedra californica, which is pretty typical to the Mojave Desert. Eriogonum fasciculatum, variety polifolium, which is a variety of fasciculatum that is specific to desert climates. Gutierrezia californica, the Eastwoodia elegans, which is the San Joaquin Desert endemic. And you also get Hespero yucca whippley in there. So here's another good example of San Joaquin Desert scrub. And in this one, you actually have a disjunct population of Tetrademia stenolepis, which is pretty much like in San Joaquin Desert only, but at this very specific location is the only population I've found of it. It's actually a long distance disjunct population that's now integrated or embedded into the San Joaquin Desert scrub. So basically you have an element of the Mojave Desert scrub that's a disjunct that's now integrated and embedded in the San Joaquin Desert scrub, just further reinforcing the fact this is truly a desert. There's another example of a sort of a variant of San Joaquin Desert scrub, and in here the soils are more shallow, and you get more of a dominance of the Hespero yucca whippley yucca in there. Some areas it can just mostly consist of simply ephedra californica, and this is a view down at Carrizo Plain. It's mostly in that view, it's mostly just ephedra. So as you get progressively more arid onto the San Joaquin Valley floor, just more drier areas, you progress into Atroplex polycarpa and Gutierrezia californica or saltbrush. And in here, I've also denoted there's a lot of red brome thatch, basically, and there's a lot of red brome invasion in there between the shrubs. So as you more or less you get even more saline on that spectrum of soils, you'll pick up Atroplex spinifera. This one's mostly on clay soils, extremely sodic soils. This is at Carrizo Plain as well, around Soda Lake. And then finally, on the most extreme end, probably of the spectrum, where it's driest and the soils are most saline, you'll get a lot of halophytes. You get Allanrolfia, Frankinia salina. These are probably the most extreme examples of the soil type for the woody vegetation types of San Joaquin Desert. This is a pretty good example of the desert riparian vegetation types you'll see. So like almost like a desert arroyo. So there'll be Populus fremonti and Lepidospartum squamatum in this vegetation type. So somebody would maybe ask, if I'm out in San Joaquin Valley, how can I tell if I'm in the San Joaquin Desert? So you can actually look to the plants to tell you whether you're actually in the desert. And so if you look at this map there, the yellow and blue on it, I mapped essentially the distribution of Atroplex polycarpa, which is basically a strict endemic, essentially, of arid climates. You can see there, all those yellow dots are found throughout the Mojave Desert, the Sonoran Desert, and then they get out into the San Joaquin Desert. And then additionally, you can have Eastwoodia elegans, which are all the red points around the edge. And so another interesting thing is that you have blue oak that'll get right up to the edge of the San Joaquin Desert, but since it has no tolerance to true arid climates or desert climates, it doesn't extend out into the San Joaquin Desert. So then essentially what you have is if you are in the San Joaquin Valley and if you see that shrub, it's Atroplex polycarpa, you know for sure you're in the San Joaquin Desert. This species will show up even on the edges of like ag fields and stuff like that. It's pretty pervasive throughout the San Joaquin Desert and a really good floristic indicator that you are in the true arid desert climate of the San Joaquin Valley. So I'll now go on to talk about some of the more unique desert annual Formland vegetation types you can find out in San Joaquin Desert. And so this is a vegetation type that occurs on the sandy soils and sand dunes. And for sandy soils in San Joaquin Desert, a lot of these are actually derived from sandstone if you're in the hills. And if you're in the valley floor, it's alluvium that's generally eroded and deposited from sandstone formations in the hills. These soils are generally chemically neutral. And by that, I mean they're not very saline. They don't have they're not really like alkaline and stuff like that. These soils are generally well drained because they're sandy, and they tend to be very drought susceptible on south slopes. So this is a view in western Fresno County, and some of the Santa Clara chapter CMPS folks and other CMPS folks have attended this wildflower walk I've done in various years to Monroe Dunes on Monoclonal Ridge. And so this is a view of that. This is a high sandstone ridge at the western edge of the San Joaquin Valley or San Joaquin Desert. So in these situations, you actually get some very interesting annual plant species sorting on these sandy soils. And these annual plant species will sort according to whether the slopes are south aspects or north aspects. So what's going on here is the south aspects of these slopes that face south towards the sun are warmer. They're essentially drier. They're a drier microclimate. You could think of this microclimate potentially as equivalent to actually the Mojave Desert. On the north aspects, it looks sort of greener there on the right. These are cooler, more or less these two slopes, the green slope on the right and the brown slope on the left, they have the same soil types. They received the same rainfall during that season. The difference is that south-facing slope received more solar radiation. It's warmer and drier. And so this microclimate actually has effects on the species sorting on these ridges. So what you'll see is this kind of regular pattern on these north aspects on the sandstone ridges. You'll have San Joaquin Desert species of Monolipia lanceolata, Facility distans the Amsenki of Fricata. I call this typical San Joaquin Desert flora, kind of on the north aspects. But then you go over the hill on the south aspects, looks totally different. You'll see species like this. You'll see Enothera deltoides, Abronia pogonantha, the pink one here, Calanthus inflatus, the desert candle, so the yellowish one with the purple top on it. Manzilia finis, and many other Mojave Desert disjunct species on these south slopes. So there's just another good example of that on the south slopes. It really is looking like a desert out there. You also get very interesting other disjunct species. This is Stillingia linearifolia. This is a monocline ridge there. This is another long distance disjunct from the Mojave Desert. And I've really only found one population of this there at Monocline Ridge, existing as a long distance disjunct on the south facing slopes. Here's Rumex hymenocephalus, which is also a Mojave Desert disjunct grown out there on these sand dune patches that are on the tops of the ridges. And on Monocline Ridge, these are called Monvero dunes, is the name of those. And off there in the distance, you can see the San Joaquin Valley floor and the patchwork of aglands across the landscape. There's another view there of the Rumex. Here's some more Mojave Desert disjuncts up there on the Monvero dunes. You have Stipa hymenioides, sandgrass. And here's another weird disjunct, Dichoria canescens. It mostly occurs like in sand dunes out of Mojave Desert. And there's one spot on the Monvero dunes and Monocline Ridge. This has become a disjunct little population out there. So there's a view of, or a picture of the Dichoria canescens. Common name of this is called twin bugs. These weird little seeds that look like bugs. So somebody would maybe ask, like, how did these get here? And my best guess is that it's possibly migrating songbirds from Mojave Desert into the San Joaquin Desert that have eaten seeds in the Mojave Desert possibly, and then flown along the western edge of the San Joaquin Desert, and then just the seeds happen to drop off in the right place, the right habitat for them, and they're growing there. And it's indicating very clearly that it's a desert landscape. They were transplanted or essentially dispersed from the Mojave Desert into the San Joaquin Desert, and they're persisting there. Here's another view, of just the Monvero dunes looking very desert-like. So another very unique desert annual Formland plant community that you'll find out on the western edge of the San Joaquin Desert occur on these acidic marine shales out there. And this is another wildflower kind of field trip that I've done out of Pinot Hills. This is at Right Angle Canyon. And so these plant communities, they are mostly occur on these very acidic marine shales that are rich in sulfur, selenium, and sodium. The pH of these soils is quite acidic. The pH is about 4 to 5 The soils have quite high selenium concentrations. So I describe these essentially as being chemically extreme substrates. And the soils they're very shallow. It looks like there's soil depth there, but it's the equivalent of bedrock. It's just very soft bedrock, soft shale. And so these soils are quite poorly developed. So one of the endemics you can find there is a strict San Joaquin Desert endemic. Is Amsenki of Fricata, is a very showy Amsenki that occurs there. This is a CRPR list 4.2. Very pretty flowers. This is a very showy a flower or a very large corolla for an Amsenkia, probably the largest of the Amsenkia corollas, and attracts tons of pollinators. There's another strict endemic of these acidic marine shells. It only occurs really on these acidic marine shells out there. Is Eriogonum vestitum. It's called Idria buckwheat. And this is a CRPR list 4.3. We're on these really extreme soils. There's a picture of that guy. And then there's this one as a perennial buckwheat, is Eriogonum nudum. This is a specific variety called indictum. This is pretty much a strict San Joaquin Desert endemic. Flowers really late into the summer. Yeah, so a pretty unique annual Formland specific to the San Joaquin Desert with a bunch of rare plant species in it. So here's yet another very distinctive desert annual Formland type that occurs in the San Joaquin Desert. And this one occurs on a soil type that I call Virtic Clay. So these soils are basically derived from that same acidic marine shell that you see there that I just talked about. They're just more developed soils. And these soils, so that marine shell is basically a clay shale weathers to produce these clay soils. And these are extreme high shrink swell smectite clays. Are physically extreme. They absorb a lot of water. And then during the summer, they dry and there's giant cracks that form in the soil. So as you can imagine, these are pretty hard on plants. And then additionally, these soils are chemically extreme. They're often, the pH can be weird. They can be alkaline or they can be acidic. They're often quite sodic or saline. And in this photo, which is sort of a soil profile, you can see there the clay soil, pretty good development on that. Then below that is the shale with a lot of sodium and gypsum accumulation. And so on these soils, with a combination of the soil type, differences in slope, slope angle, and then aspect, either it's north aspect or south aspect, it creates a lot of many different niches essentially in this landscape. What you'll get is you get a lot of species sorting that to our eyes, we see as a wildflower display expresses as species color patches across the landscape. Looks like a really dazzling display of color across the landscape. And so what's going on there is you got a bunch of species sorting. And so this flora has a number of very rare, strict San Joaquin Desert endemics. And so in here you have Facility ciliata, which is not necessarily rare. It's the purple one there. But the Lepidium geridi subspecies album, that one is quite rare. That one, this subspecies, it's no longer recognized anymore. But that subspecies pretty much only occurs like at Pinoch Hills and Toomey Hills. And that one's a CRPR list 1B. And for this photo comparison in the foreground there with all the color on it, that's the Virtic Clay soil. And in the background there on the upper right is actually sandstone. And you can see how huge the difference is between the soil types. This is pretty typical of San Joaquin Desert. You have a lot of like really extreme differences left patches of soil right next to each other. So there's another really good example of this Virtic Clay flora that produces really spectacular wildflower displays in the San Joaquin Desert. This is akin to a creek in western Fresno County as well. So there on the right is a rare San Joaquin Desert strict endemic, strict Virtic Clay endemic. It's a CRPR1b, is Media radiata. And so that's occurring essentially on these north-facing slopes. And then on these south-facing slopes, you have a different strict San Joaquin Desert endemic, also a strict Virtic Clay endemic, another different, very rare species, Denanger Hollyana. So these floras, you got a lot going on. You're gonna have very showy displays. There's another good example of this flora, of the Virtic Clay endemic flora. Here you have a combination of Phacelia ciliata, which is the purple, the Denanger Hollyana, which is the yellow, Lepidium druidi subspecies album, which is kind of a cream color in the background. And then lastly, this species that I recognize, I found the species like, what the heck is this? And I came to realize this is actually an undescribed species, that there were a few records of it, a few collections of it. People have been identifying as Extraplex joaquinina, which is described, but this one has features that are not quite that species. So this is the species I'm working on now. I'm describing the placeholder name I'm calling is Succulenta. And this one is pretty local endemic. It's mostly only occurs on these Virtic clays that came to a creek. So this one's going to be more or less probably CRPR1b in there as well. So here again, you have a Lepidium druidi subspecies album. This is above the, so in this photo, you get a good combination of the acidic marine shale floor where the orange is, the Amsenki of Fricata, and then on the Virtic clay soils, immediately adjacent to it, derived from that acidic marine shale, is occurring the Lepidium druidi. So here's subspecies album, sort of a light yellow color petals. So here's the one that's subspecies druidi. This one occurs around Soda Lake down at Carrizo Plain. So these two subspecies are no longer recognized anymore, but I kind of still like to recognize them if I can. So the very interesting thing is, these two subspecies are widely separated, Pinoch Hills all the way down to Carrizo Plain. They're still in the same soil type. They're in the same niche. They're on these extremely sodic Virtic clay soils. And there, the population of subspecies druidi is very extensive. You can see the yellow extending way across the landscape there. So Carrizo Plain, I know a lot of you probably are pretty familiar with it. It's really kind of probably what most people would associate with San Joaquin Desert. It has very spectacular wildflower displays. And that's one of the fabulous things about the desert Southwest is in dry years, it can look bleak, barren, but in really good rain years, it can produce just really dazzling displays of wildflowers. And here's a good example of that, and of an actual rare, yet another rare San Joaquin Desert endemic species, Leia munzii, of which there's a very large population at Soda Lake. And this is the CRPR1b that occurs on clay soils there. And here's just another photo of Carrizo Plain during the super bloom a few years ago. And here you have Calanthus anceps, the pink. Mostly occurs in San Joaquin Desert, but a little bit outside of it. So I'd say it's, a near endemic, and then occurring with Monolopia stricta on these clay soils. And Monolopia stricta is a strict San Joaquin Desert endemic. There's another great dazzling display from Carrizo Plain during the super bloom. And here again, you have Phacelia ciliata, the purple, occurring with Monolopia stricta, the yellow. So yeah, just really spectacular displays of chrysoplane. It's probably one of the best examples of intact flora of the San Joaquin Desert. So with only 40% of the San Joaquin Desert ecosystems remaining, what can we do to conserve what is left of the San Joaquin Desert? And so probably one of the best strategies there is to simply designate lands as conserved status to protect them from development. You know, a very large proportion of the San Joaquin Valley floor has been developed to ag land and various other uses, you know, urban, I mentioned, and oil and gas development. So conserving lands or putting some kind of conservation easement or you know, mitigation land for other land developments or designations of federal public lands as area of critical environmental concern or national monuments. Those are some of the best ways we can protect these lands and prevent further loss of these very rare ecosystems comprising the San Joaquin Desert. Other ways to conserve what's left of the San Joaquin Desert and the ecosystems that are there is to ensure that there are migration corridors for the species that are left there, and to enhance those corridors wherever we can, because these species, you know, I'm not talking about just plants either. There's the, you know, obviously animals out there, and all of the species, they need to be able to migrate, and they're especially going to have to do so with climate change. So the more that we can connect the fragments of habitat that are left out there, the better it will be for these species. Third would be to manage the lands to limit non-native plant species invasion and other adverse conditions that are competing with and impacting the native flora that is there. Species like red brown that just carpet some areas of the San Joaquin Desert are adversely impacting the native plant species and some of the San Joaquin Desert endemic animal species as well. So the more that we can prevent those invasive species from arriving and dominating the landscape, the better for these ecosystems. And then lastly, wherever there opportunities exist to restore degraded existing habitat and to rebuild San Joaquin Desert ecosystems on retired agricultural lands, for example, or other lands that could be reclaimed as ecosystem or habitat, or I call them quotes, rewilding, those are other opportunities that I see where we can make links between existing areas of intact habitat to provide those migration corridors and just habitat links out there. So habitat fragments, these still exist on the San Joaquin Valley floor, as a patchwork of them out there. And so wherever there's opportunity, so this photo here was essentially a patch of, you can see this is saltbush scrub, more or less an intact patch of San Joaquin Desert saltbush scrub. I took the photo from Interstate 5 looking out across this patch, and on the other side of it is an almond orchard. You know, in a few decades, if that almond orchard not producing anymore, there's no water to farm it anymore, you know, it becomes fallow ag land. If that could be reclaimed and restored, the San Joaquin Desert, and link it with another intact patch, those are good opportunities to protect what's left of the San Joaquin Desert out there. What's the plan? You know, is there a plan, you know, for conservation of the San Joaquin Desert? Well, one of the plans that exists for conservation, recovery, protections for San Joaquin Desert ecosystems and the endangered and rare species that exist there is this recovery plan for upland species in the San Joaquin Valley. And that map there, I know it's probably very difficult to read or interpret, but that's a sort of a broad overview of the strategy for conserving the intact areas of habitat that are left out there, and then proposals for areas where there can be migration corridors or links between those areas. And so this recovery plan provides a blueprint or an overview for conservation and recovery out there in San Joaquin Desert. And for various land management agencies out there, there are other management and conservation plans, overarching management plans out there. For my field office, we have the Resource Management Plan for Southern Diablo Mountain Range, Central Coast of California. That covers San Joaquin Valley and San Joaquin Desert. Bakersfield Field Office basically has the same, they have their own resource management plan that covers their lands for management, conservation, and protection of some of those areas. Additionally, there's a proposed Bakersfield Habitat Conservation Plans. There's a lot of other plans out there that are all sort of linked together, in particular through that recovery plan for upland species for conservation and recovery out there. But there's still a lot of work to do in terms of conservation and protections and recovery of the species and the ecosystems that are left out there in the San Joaquin Desert. What about climate change effects on the San Joaquin Desert? So, earlier I showed that map of the current Coppen climates for the San Joaquin Desert and talked about the climates that exist in the San Joaquin Desert. So essentially what you have there is you mostly have this BSK, which is, it calls it a cold semi-arid climate. It's basically it's pretty much an arid climate. And then the southern part of the valley there, you have cold desert and then hot desert. So, with climate change, the future projected climate is essentially, it's going to be warmer, and it's also projected to be drier, or essentially more arid. And so that map on the right is a projection of what the Coppen climates will be in 2100. As you can see there in the San Joaquin Desert polygon, essentially what you get is a verge of the climates on more or less more like a Mojave Desert analog type climate, hotter and drier. What it looks like is that the San Joaquin Desert climate, so that BSK almost gets rammed toward the west and to the north. And so it's not really clear, obviously, what will happen, to the San Joaquin Desert ecosystems. Will the existing species, since they're already desert species, sort of still maybe be tolerant of these more Mojave Desert-like climates? Time will tell. But more than likely, the San Joaquin Desert, it will start to trend more towards more like a Mojave Desert-like climate. And the rest of the Mojave Desert will be potentially more like a Sonoran Desert type analog climate. So maybe what can we expect to see? So I showed that photo of that south-facing slope, a monocline ridge. And so I got to thinking about this. Could that actually be sort of potentially an analog for maybe what the future would look like for some of these floras out there in the San Joaquin Desert? So maybe what we already see out there in the San Joaquin Desert on these south slopes is potentially what the future broadly, what the San Joaquin Desert flora will start to look like. And so maybe what we'll see is that these patches of more or less Mojave Desert flora that already exist out in the San Joaquin Desert, we might see these expand and dominate more throughout the San Joaquin Desert. And so with that, lastly, I just want to put a plug in for Emma Fryer here. She received funding for the San Pierre's Santa Clara chapter. Actually, she received a student research grant. And she is basically researching the Virtic Clay endemic flora, that I just talked about. Her title of her research is Getting the Dirt on California's Super Blooms, and she is studying native plant community assembly in the San Joaquin Desert and using these Virtic Clay plant communities as a model for plant species sorting out there and formation of the spectacular and dazzling super bloom displays that we see out there. And she'll be presenting actually the CNPS Santa Clara chapter on August 18. So I just wanted to put a plug in for her. I also wanted to thank CNPS Santa Clara chapter for funding her research, and promoting research in the San Joaquin Desert flora. Yeah, there's just a lot more work to be done to increase recognition of the rare flora out there in the San Joaquin Desert. Lastly, I just wanted to recommend some additional reading for San Joaquin Desert if you want to read up on it. These are some really good publications. The one on the left, California's Fading Wildflowers by Richard Minnick, was really good as historical accounts of San Joaquin Desert. He has early accounts from the Spanish explorers when they crossed the San Joaquin Desert, before it was ag land, before it was extensively invaded by weeds. Some of their descriptions, it really sounds like a desert. They talk about dust storms and things like that. So that's a really good read if you want to get a better feel of what the San Joaquin Desert and also just what California's wild landscapes were like before invasion and a lot of development went on. And then the publication on the right, the Rewilding Agricultural Landscapes, is a very recent publication. And this is just highlights the development that's gone on in the San Joaquin Desert and talks about opportunities for restoration in the San Joaquin Desert and conservation out there. And so the Rewilding Agricultural Landscapes is a good read about that. And so that's more or less concludes my presentation. And with that, I'll take any questions that you might have for me.
Thanks so much, Ryan. That was terrific and so much information in there. So I'm going to have to watch it again.
Sure.
But I also, we love hearing about Emma because we're just working through our students. They'll be presenting before our next few programs. So
yeah,
that's terrific to hear.
Yeah.
So, and we're hearing that from the scholarship committee chair is hands up or in our YouTube. So I just want to let you know, we have a lot of folks who got wind of this program who are from other parts of the valley, from Sequoia chapter, which covers Madera, Kings, and Fresno. So we have some people from there. Sure. And also Kern chapter. So the subject is of interest, and East Bay chapter. So sure. It's great. So we had a question, what is CAM? And someone answered it that CAM is a form of photosynthesis that is an adaptation to arid conditions. Did you want to add anything about that?
No, yeah, that pretty much summarizes it. It's a physiological adaptation that's seen in species that are for drought adaptation. Yes.
There was a question about, this was early on in the program, about whether the Carrizo was included in the San Joaquin Desert.
It is, yes.
Yeah. It's probably the one we all know most.
Yes, it's a very prime and excellent example of San Joaquin Desert, and it's excellent. It's been preserved in perpetuity as a national monument. Yeah.
It didn't look like this year, though. It didn't look like.
No. Yeah, there were pretty good super blooms in 2017 and 2019, and that's where from most of my photos are from. Yes.
I think a lot of us were there. So I also wanted to mention, you mentioned the ephedra in the Carrizo Plain, and I remember seeing it every time it had white fiesta flower rolled up into it. I don't know if you've ever noticed that. Yes, I've seen that. And I've also noticed there's definitely a pattern of fiesta flower occurring in it. It's almost like that is like its niche, is that it likes to occur in the ephedra for whatever reason. I don't really know why, but yeah, I've noticed that as well. Let's see. Is there somewhere a list of all San Joaquin Desert scientific literature? We have a number of students here today where scientific literature may be found thanks in advance. I guess they're looking for a bibliography. And then someone did reply that Endangered Species Recovery Program's website is a good place, good start. That's easy to get to online. Yes, I agree. It is. And my hope is also to actually produce a
publication on the flora of the San Joaquin Desert here soon. I'll probably submit it to Madronio, so folks can look for it there.
And for anyone who's not sure, that Madronio is the publication of the California Botanical Society, where a lot of new species in California are introduced. So where can the lists he is displaying be found? I don't know if they're publicly available yet. Is that correct? I guess it was
yeah. Right now it's yeah. I mean, I could send a list if folks are interested, and the list of species, you know, that I've identified as strict endemics, as near endemics, and as disjuncts. But there is not like a comprehensive list of all species in San Joaquin Desert that I'm aware of at this point.
Okay. So I can talk about that in a minute. I don't know if you want to put your email out there or, but we had a question about sodic soils. It was when you were showing Soda Lake and alkali soils. Did you want to speak to that anymore? Just what they are?
Oh, sodic soils, it's essentially the same as saying saline soils. And so sodium, like salt, sodium is basically salt in soils is really hard on plants. Some plants are specifically adapted to dealing or coping with saline soils, like the halophytes. They will uptake sodium, you know, actually into the leaves, and that helps them get water out of the saline soils, basically. But sodic soils, it basically just means saline soils.
Thanks. Let's see. Well, there was a question about the high selenium levels in Central Valley wetlands that was causing deformities in waterfowl. And I remember that as Kesterson Reservoir, but the question was it caused by these soils that you were highlighting?
That's correct. Yeah, the acidic marine shells that are high in selenium. So the selenium that accumulated in Kesterson actually originated from leaching from these acidic marine shells. You know, you have rainfall on these marine shells, it leaches through, that goes to creeks, which then go to diversion canals, which then went to Kesterson. And essentially what happened there is you got an accumulation of selenium there because the water was, all that water from that side, western side of the San Joaquin Valley went to Kesterson. And then there was a lot of evapotranspiration and concentration of the selenium there. And that adversely impacted waterfowl and caused deformities. So the answer is yes. Those acidic marine shells are the source of the selenium.
It had to come from somewhere.
Yes.
Yeah. So there were questions about you doing tours, which you have done in the past with BLM.
Yes.
And public access in general. I know there's some public access, but it's limited.
Yeah, so the Monroe Dunes Monoclonal Ridge site, those are BLM lands, but they're surrounded by private land. And so that's what's called landlocked, is there's no public access to there. There's no like public right-of-way or county road or something to get to it. And so in the past, I've done tours there. Those are like one-time events. And so for those, basically those I only do those in good rain years when there's good wildflower displays. And usually I'll start letting people know, and I'll put out announcements about mid-February if it's a good rain year out to the various CMPS chapters in the surrounding areas, then I'll do a tour out there. In the past, I've also done a tour to Right Angle Canyon for the photos I had for the marine shell there, which also have spectacular wildflower displays. And in the future, I'll continue to do those wildflower tours for people. Right now, Canyon actually is publicly accessible. It's just people can't drive very close to it. So when I actually do the tour, I can get people pretty close to it within at least a half mile of it for a hike. And so it's a little more feasible to get people there under a tour situation.
I think, thank you. We're grateful for looking forward to that sometime. But I think the best way if people want to get notified is to get on your chapter's mailing list, join your local chapter, and we'll put that notice out if it comes. So
yeah.
And there are human activities, other human activities. I guess they mean recreational on the BLM land in this desert, but there's also oil drilling or
So yeah, in different areas of remnants of the San Joaquin Desert, there's been oil exploration there, even as on RBLM lands. Kettleman Hills, for example, most of ours has occurred down in near the Coalinga oil field, so Kettleman Hills, for example, and in Bakersfield Field Office area, some intact ecosystem, San Joaquin Desert ecosystem areas, like down near Taft, if people are familiar with that. So yeah, so that's one kind of like impact. There's various recreation impacts that do happen on the San Joaquin Desert areas. In our field office area, there's target shooting impacts. They're generally like smaller, kind of localized, but it's a fair amount of trash and kind of impact to some areas. In some other areas, there's occasional like off-highway vehicle, like trespass kind of impacts. I would say those are the main ones.
Mm-hmm.
Yeah.
Some of these places are hard to get to, though, that you've shown today.
Yes.
A lot of gates.
Yeah.
So there was a question about the ownership regime through the San Joaquin Desert foothills. It's clear that BLM has some large parcels, but is there also private land?
Yes. Yeah, there's a lot of private ranch lands that include remnants of the San Joaquin Desert. And, those are quite important, to preserving these areas of San Joaquin Desert. There's a rich history of rich ranch history and ranching history in California. And I showed those photos, of the areas that are choked out by red brome. And grazing is actually pretty important in terms of controlling red brome. It's one of the few treatments or management tools that we have to really controlling red brome. It's so extensive at this point that livestock grazing is actually a pretty important tool in terms of reducing the competitive intensity of red brome with the native annuals. Mm-hmm. Generally, what I've seen is areas that are intensively grazed or people regard as like overgrazed or hammered or look like just like bare dirt. Those are often some of the best areas actually where you see like the really good displays of the native annuals. And it's because of competition with red brome, that accumulation of thatch has really been reduced.
Thatch is always the enemy. Yeah. Thank you. There was a follow-up question. I'm trying to group these a little bit. Are there any land trusts working within these desert areas? If so, who? And it was mentioned that Center for Natural Lands Management, California Fish and Wildlife hold a lot of the mitigation lands as well.
That is true, yeah. Yeah, CNLM, they manage a fair amount of mitigation lands in the San Joaquin Desert. The Nature Conservancy is often looking at various whenever ranches come up for sale, even with our office, there's been discussions of TNC acquiring ranch lands for conservation purposes and then transferring to BLM, maybe for conservation areas. So TNC is a major player, CNLM for mitigation. And there are various different landholders, include Fish and Wildlife Service has some lands that they have, and then
it's a complex ownership.
Yes, yeah, it's a complex ownership of public land, private land. There's a lot of landholders in it.
So you sparked some interest. If we got a couple more questions, if that's okay.
Sure, yeah.
So we have sparked some interest in the wetlands, the historic wetlands. So what happened to Tulare Lake? Are there any wetlands still remaining in the desert? What plants would be special to those areas? And will the San Joaquin River ever flow again to the Delta? This is a lot of questions about wetlands. So I don't know what you want to address.
So unfortunately, a lot of the wetlands were on the valley floor, and a lot of the valley floor was developed. Unfortunately, Tulare Lake is now when you look at it on a map, it's been constrained to a tiny little square. The lake bed has been drained. It's now being farmed. It's been farmed a long time now. There are intact remnants of wetlands within the San Joaquin Desert, but yeah, there used to be extensive like tule stands around Tulare Lake.
And that was mostly drained through agricultural practices?
Yes.
Air pumping?
Yeah, and so another really good reference, that I can recommend that talks about the wetlands, the San Joaquin Desert, and it's a really good read, is called Indian Summer, and it's called The Traditional Life Among the, I hope it pronounces correctly, the Shoinumni Indians of California's San Joaquin Valley. And essentially it was this young boy named Thomas Jefferson Mayfield lived with the Native Americans in the Tulare Lake area in the late 1800s. And so he talks about living with the Native Americans and going out on Tulare Lake and stuff like that. It's a really good read that talks about, what the San Joaquin Desert and especially the wetlands were before all of it was drained and converted.
It's called Indian Summer.
Yeah, that's the main title. It is Indian Summer. It's Thomas Jefferson Mayfield.
Thomas Jefferson Mayfield. Okay, great.
Yeah.
Historical ecology, sometimes it's hard to come by.
Yes.
And segueing into that, someone asked do you know of any efforts to involve Indigenous people in restoration and management?
Certainly with our field office at this point, there hasn't been in San Joaquin Desert, but we have worked with like Amamutsun tribe, the Ohlone folks. Yeah, we have worked with them. Yes.
And this other part of our chapter somewhat too.
Mm-hmm.
A couple more people keep writing more stuff in the chat.
Sure.
So what's the level of effort? I think I know the answer to this one. What is the level of effort needed to convert invasive annual grasses to bunch grasses or native forbs?
Well, so, as I mentioned, this is technically, it's not a perennial grassland. That was sort of like the misnomer of the San Joaquin Desert, was that it was a degraded perennial grassland. The early ecologists thought this was essentially the equivalent of, like Sacramento Valley, like native perennial grassland. It never was that. It was technically desert annual forbland. So anyways, yeah, for areas that have been extensively invaded by red brome, there can still be remnant native annual forbs in there. What it takes is reducing the competitive pressure from red brome on the natives to give them a chance, to get back in there and to get a foothold. And so grazing is a pretty effective tool on that. It's one of the more feasible tools. There's probably other tools out there that are less feasible, like prescribed fire. We haven't done any of that in particular in San Joaquin Desert. People could maybe try that, but overall, I'd say grazing is the primary one. Primary tool.
The level of effort is high, though, I think, generally.
Yes.
Yeah. Okay, so we got a lot of chat going on talking about that book, the Crossing the Pacheco Pass is seen as San Joaquin for the first time, like a crazy quilt of wildflowers. And I myself have found some old National Geographics that had pictures of Kern County and Arvin. I'm not sure if that's included here, but I mean, the flowers were just incredible, even 80 years ago. So
yeah, that old photo from National Geographic, that was near Wheeler Ridge, at the base of the grapevine there, essentially. And that was San Joaquin Desert. Back in the, I forget when that photo was taken, the 40s, or I think it was the 30s or 40s or something like that.
Yeah. There's a little, little comment in here that just for everybody who's listening, we say forbs is non-woody plants, particularly wildflowers, not grasses, not shrubs, not trees, but all flowers are, say, forbs. That's what we're talking about.
Yeah, the native annual forbs, you could call them wildflowers if you wanted to. Yeah, it's the native annual wildflowers that you see.
I think we're almost done here. Someone asked, can we get a link to the comparison of current and projected Coppen climate for California? Is that available?
So that data, so the source there is Beck et al. Is 2018. And so that's a GIS data. So those maps, I mean, I don't know how I would do it, but I could make those maps available to folks. But the source data is Beck et al. 2018. That person actually did the current climates and the projected climates for the entire world globally. And so I just made these maps from that data essentially.
So maybe I'll say with that.
Yeah, I mean, if you had a way to, I don't know if you have a way to on your CMPS website or something to actually post like the presentation, like the PowerPoint presentation, I'm sure.
Yeah,
Ryan.
go ahead, Vivian.
Oh, I was going to say, Ryan, I'll send you an email, but if you email it to me, then I'll post it on the website and I'll send the link to everybody.
Okay.
Registered, and I'll also link it on the YouTube description so people can go back and look at the recording later and get to it.
Sure. Yep.
I just have one more question. There's a proposed Del Puerto Canyon Dam. It was Del Puerto Canyon Road in Stanislaus County. Is that part of this province? Do you know?
So San Joaquin Desert, I don't know if you're able to see my current screen. Am I on the slide that shows?
You're on the climate change slide.
Okay. Yeah, so if you look on the very northern part of what I've delineated as San Joaquin Desert there, it forms almost like a little neck at the top, and sort of like on the SNJV there, Del Puerto Canyon is more or less like straight to the west of that. So there's a very narrow band of San Joaquin Desert essentially that passes through there on the very bottom end of Del Puerto Canyon there.
Interesting.
I'm not exactly sure like where the dam was proposed to be, if it's farther up the drainage or where that is. But
Pretty close to I-5, yeah.
Oh, pretty close to Interstate 5, yeah.
Yeah.
So it could impact the flora that's there. Sure.
I think that's everything. Madeline, did you have anything else that you've seen from YouTube or anywhere else?
Judy, you got everything that I saw.
Okay, except for the part where people were saying use common names, or others were saying use scientific names. So I just left that.
Yeah, sorry about that. That's always a struggle. I guess my preference is always to use the scientific names because, you know, there's more than one common name sometimes for species. But I get that it's difficult to know.
Yeah, so these subspecies we've never heard of. But
may I point out that that the slides contain the scientific names in print, so you can look them up on CalScape and get their common names.
Or CalFlora, yeah. CalScape,
Sure.
CalScape, the CMPS project for landscaping. It's great. It's great. I think we've got everything. If anybody has any questions or wants to contact, we can send, Vivian, we can have them send an email to the info at our generic chapter address, and we'll get that information from Ryan. Is that okay?
Yeah, sure, that's fine.
Okay, so it's info@cmps-scd.org for everyone who has further questions. And if nothing else, then I guess we're done, and we really appreciate your time and all the effort you put into this presentation, which was very complete and very thorough. Really appreciate it.
And actually, sorry. I was going to just remind people that if they want to get a copy of the chat, they can save it out themselves. If you go down to that bottom part of the chat where there's a ... button, and you click on that, it should say save chat, and then you'll be able to save your own personal copy of it.
We will get the chat to you from YouTube and Zoom, Brian. Thank you. So we're getting a lot of thank yous in the chat. We'll make sure you get them.
Yeah, thank you very much for inviting me.
Yeah, well, I think we owe you a speaker dinner, which we are unable to do right now, but maybe in the future. So thank you very much. Vivian?
I think that wraps it. Thanks a lot, Ryan. That was an amazing talk. And hopefully we'll get to see you out on the trails at some point.
Yep, me too. Yep. Hope to do more of those wildflower tours in the future.
Yes, definitely.
And more rain, please. Yes.
Yeah.
Well, thanks everybody for joining us, and we'll be signing out now. So hope to see you again soon. Bye-bye.